And next we have Steve from Opacity, and he'll be delivering a talk on verifiable data. What is it? Why do we need it? And how Opacity makes it easy. And just as a reminder, Opacity is one of our lead sponsors. So please give a warm welcome to Steve.
Thank you. Yeah, as she said, I'm Steve from Opacity Labs, here to talk to you about our product and why we built it the way that we built it. Some of my first few slides here I can probably speed run through if my slides come up. There we go. So on socials, I'm 0xwildhair if you want to connect with me. Hirsch was supposed to give this talk, so I wanted to start with a quote from him. We live in a world with a poverty of verifiability. I think that's very true. Very excited to see what possibilities we open up by introducing verifiable data to the world. It's just super exciting to me. We have the chance to change the way the internet works. We have the technology to do it now. We have lots of teams building really exciting infrastructure and some apps that are starting to get built, and looking forward to see what gets built on that. The last two talks covered a lot of my first few slides, so I'll just sort of speed run through them. Verifiable data is something that's been signed off by some authority. Ideally, we'd be able to generate a ZK proof from that, and it'd be something with enough integrity that we would want to, or we'd feel free to base economic transactions based on that. And our large corporations would feel the same way, that this would be basically rock solid. Why do we need it? We're building these hardened crypto economic systems. From that point of view, unverified data is essentially the same as noise. So we need verifiability to be able to use any real world data in a blockchain. It'd be real easy, Henrik mentioned in his talk, it'd be real easy if the servers would just authenticate the data themselves. If it came pre-signed, then none of this would be necessary. We could just use the data. There's some reasons that they don't do that and won't do that, or maybe eventually they will, but there's some liability reasons, and also there's some data that companies would not want to necessarily verify or share. For example, a lot of early blockchain, early Ethereum product ideas were things like decentralized Uber, decentralized Airbnb, which are still great ideas. But there's issues. One of those issues is a bootstrapping problem. If I want to run a decentralized Airbnb, it'd be real helpful if I could just port data from Airbnb. So if someone wants to rent their house on my network instead of Airbnb, or in addition to, if they could just transfer their profile over. Well, Airbnb's never going to provide that data willingly, let alone cryptographically signed to prove that this information's true. So based on TLS, the S in HTTPS, we've covered this a few times already today, but we've got certificate authority and end-to-end encryption, but it's symmetric encryption. Just quick sort of overview of how that works. We verify a certificate, we do a key exchange, and now we're free to exchange this encrypted data between the client and the server. That uses a Diffie-Hellman key exchange to derive an AES key. But like I said, it's symmetric. Both parties have that key. So the information that is exchanged, it's secure between those two parties. But outside of those two parties, I can't transmit that to a third party and have them rely on it because I had the encryption key. I could make it say whatever I want. So we've got to add some complications. So there's a few different options on ways we could do this. We could just offload the entire thing to a TEE. It's a hard trust assumption on the manufacturer, and as Merrick mentioned, the TEs have been hacked. We can proxy through an intermediary. A couple downsides to that, privacy being one of them, and also if you're communicating to another server through a data center, they can easily block that IP. And then the third option is to use MPC with garbled circuits and oblivious transfer. And at Opacity Labs, that is the choice we went when building our eigenlayer AVS that acts as a notary as a service. So bottom line, MPC is the best approach to building a ZK TLS protocol that's going to work at scale. Good censorship resistance, it's privacy preserving, and it's probably legal in most cases. So, okay, are we done? Can we bring data on chain now? What's the point of having a cat if you can't use them for memes, right? So the problem is collusion. If the notary and the client, the user, if they collude, you can put any information you want into that, whatever data you want, you can notarize it if you control both the notary and the client. So if we can't just do two-party MPC alone to have verifiable data that we can use on chain, then can we use more parties? Merrick mentioned this as an option also. But the bottom line here is, yes, it's possible, but the mathematics behind it just increase the latency to a point that it's not practical, at least not yet. We need some major improvements in the cryptography before this becomes practical for production. The problem being that your server request is likely to time out before we're able to do all the computations necessary here. So we're stuck with two parties. So now, what if we do it several times? What if we do, use several notaries and just do this two-party MPC dance over and over and over again? Well, problem here is that we can slash honest nodes. So we're running an AVS with operators. If an honest operator can get slashed under basically any conditions, we're not going to have any operators. So that's a non-starter. The reason behind that is if I'm proving a bank balance, right? And let's assume an honest user as well, right? I'm going through this MPC process. It's going through 10 different notaries. And let's say I switch over to another screen and buy something on Amazon or pay a bill or something. My bank balance changes partway through the process of running these multiple notaries. Then I have some notaries that report one value and others that report another. They could end up in notaries that are running their software properly, they're not colluding, they're not giving bad data. It could lead them to getting slashed, and obviously that's not going to work. So what can we do? As Merrick mentioned, we're using a identity-based approach. Another Hirsch quote here is a subtle shift in perspective versus cryptographic wizardry. I just like the way that sounds, but it's true. Instead of solving this with complex math, we're solving it very simply by paying attention to a history of requests. So out of all these possible notaries or operators that we have on our AVS, one gets picked at random. But before that happens, we make the user commit to a hash of the response that we expect to get back from the server. Once the notary's selected, they do the MPC scheme and prove the verification. Now, if they're trying to collude, if they're looking for a colluding node amongst our operator set, they can retry this over and over again. And then that'll look like what we have here on the right. We'll have a failed request, failed request, failed request. They finally land on the colluding node, and success. They get to say whatever they want and have a proof. The problem for them is that since we've been tracking these requests, we have a history of bad requests. And so we can just assume that they did this. We've got a bad operator in the set, and it's very easy to see. Since we're likely all crypto native here, of course, the logical next question is, well, addresses are free. Why don't I just spin up a new address for each request to prevent tracking that history? And here we do get to use the committee that I discussed earlier. We can have multiple operators verify a user ID for a specific server, because that's not going to change. So now we have a user sign-up process that essentially involves them signing into this server. So if it's Twitter, I log on to Twitter, and I let one notary see me do that. They sign off. We go through that process a few times. All the notaries agree, yes, this is the user identity associated with this account, and we can tie that back to this specific address. And now we can track those requests to that one address. And that brings us back to this history of bad or failed requests that we can monitor. You can see them on chain. The other notaries will monitor the history, and once you have a few failed requests, we're just going to stop receiving requests from that address. Okay, so cool. What do we do with it? Which this is a really interesting question. There's been some ideas thrown around already this morning, both by Henrik and Merrick. Lots of use cases. I'd really encourage you guys to think about things that can be built, because, like I said, we're building infrastructure here. The applications built on top of it are going to be the really interesting part. I mentioned earlier the idea of basically a vampire attack on a existing network. We have one client named Nosh that's doing a Grubhub vampire attack. They'll let you port your Grubhub account into their account. So you have your full history, really knocking down the walls of this barrier to entry or this cold start problem. You can start with an existing network for your application. Another customer of ours is called Daisy. TikTok responds to the first 2 minutes of the algorithm responds very much to the first 2 minutes of interaction that you get on a post. The influencers before were just using screenshots to show, hey, I liked, I reacted to your post within the first 2 minutes. Using Daisy, that all becomes verifiable and solid. They've done pretty impressive revenue actually using ZK-TLS proofs on TikTok. There's a guy who's starting a bald chat group in Farcaster based on if you can prove via 23andMe that you have the genes for baldness. I don't know what they talk about in there. Hats, maybe. But that's a thing. This is screenshots from a sort of a toy app that we put together at Opacity, where you can look at your Neanderthal genes on 23andMe. You can prove if you traded GameStop on Robinhood during the GameStop craze, your Carta options. Basically, anything that you can think of that might be useful that is data is available through TLS. And now with these new tools, and shout out to the Ethereum Foundation for building TLS Notary, because we rely very heavily on them. Shout out to Eigenlayer for building their infrastructure that we're building the AVS on top of. But all these tools, they unlock the ability to do something that we haven't been able to do before. And I'm just super excited to see what people build on top of this in the future. So does anyone have any questions?
Orest, what's your question?
Thank you so much. What do you mean by three-party or actually multi-party computation introducing latencies that be impractical? Any ballparks you could share?
I don't have that. I actually, I asked about that myself earlier with Henrik, and no. Just, it's something that's not practical now, and no real timeline on when that would be practical.
Thanks.
Yeah.
Any more questions from the audience? Okay, so I guess we'll wrap it up there. Thank you so much, Steve. Everyone give Steve a big round of applause. And thank you once again to Opacity for being one of our lead sponsors. And now it's time for lunch, and lunch is for 1 hour. I believe we have a buffet-style spread outside and more coffee and tea. And then at 2 p.m., the next talk on the main stage is FFTs on the Projective Line by Ariel Gabizon from Aztec. He's the chief scientist at Aztec, and that's going to be one of our big keynotes. So if you're interested in that, please join us in 1 hour. Thank you.